Today, we are just going to talk about the what is cloud computing and some overview about the Amazon. I'm sure cloud computing is a buzzword in the industry and you all are aware what it is doing and all that. So let me start with that, what cloud computing is. But before that, I just introduce myself. Who am I and whether am I really eligible to train you or to give this session? So this is just a few guidelines about me. Who am I? I'm Tarun Dave. I'm having around 14 years of IT experience. Out of that, around 4+ years of only in Amazon. I've conducted more than 20 now. I would say it's almost 25 plus workshops I've conducted with the various classroom trainings and all that. 700 plus IT associates, developers, architects I have trained on the Amazon Web Services. So that's just a general background about me. Who am I? What am I going to do about that? So I hope that would give you some idea about the what is my passion and what I would be like to cover today. Moving a little bit on, if you want to reach me, you can always reach me on tarun@edureka.co. Amazon is really a passion for me. Uh, I'm a Amazon Certified Solution Architect, and the curriculum which we run for the Amazon is also designed in align with that Certified Solution Architect curriculum only. This is my link where you can reach me on LinkedIn. Uh, I would just like to hear about from you all guys about who all are you, from which part of the world you are, something if you can give background about that. Oh, somebody just asked about my email ID. I think I mentioned here. It's a tarun@edureka.co. That's my email ID. So what are we going to learn today? Let's try to understand a little bit about the what is cloud computing, different cloud models, and we would give you a little overview about the Amazon or Amazon case study. We would talk about that. And I would tell you, you all are using cloud in your day in, day out. You are using cloud. The only problem is you are not aware that you are using cloud. Otherwise, you are the daily user of the cloud. And once we progress, I would be able to pass on that message over there. But before that, it's very important to understand the cloud is a buzzword in the industry and it is going on. So Mark Benioff, he's from Salesforce, he says it's like democracy, right? Cloud services, companies of all sizes. The cloud is for everyone. Cloud is your democracy. And that's the thing. It's you day in, day out, you are using the cloud. You have the cloud. Now, what Mark Anderson has to say, every kid who is coming out of Harvard, every kid who is coming out of school now thinks he can be the next Mark Zuckerberg. And with this new technologies like cloud computing, actually he has a shot. So we have a one founder of a startup today with us, and I'm sure he must have a few dreams in his mind. And but that's actually possible. That's becoming more reality now because of the cloud computing. So cloud is the thing for us now. And why? So this is the growth market of the cloud. When you see over the period of the time, the cloud has grown tremendously over the period. Now there are three kinds of clouds being shown to you, and I'll talk about them when we progress more. But you can see how it's growing fast and fast and fast, more and more over there. This is how the cloud growth is. But what is cloud computing really? And that's why our dear friend Larry Ellison comes very handy. He says they don't call it internet anymore. They call it cloud computing. I'm no longer resisting the name. Call it what you want. He's right in a way. The people, when you go out in the market and you say something, oh, move it to the cloud, use the cloud. Now, when you ask, what do you mean by that? And the 80% people who do not understand the cloud, they would come out and say, oh, store in the internet. No, my friend, that's not the cloud. That is not what the cloud is all about. Cloud is a different thing. So they don't call it internet anymore, they call it cloud. Now, what is the real cloud computing? So before I explain, it's very important to understand the 5 attributes of the cloud computing. Now, who has defined these 5 attributes? Who has defined these 5 attributes? These are defined by the National Institute of Standard and Technology, NIST, USA. They have defined these 5 attributes. And those 5 attributes define cloud computing. If I try to explain those 5 attributes, it means it's available everywhere. Means you can access it using internet protocols. Now, Why I use the word internet protocols and not the internet only? Because it may happen that it might be just for your organization only, but your organization might be working in Delhi, Bengaluru, Mumbai. You can still access from that without going to the internet through intranet. So I use the word available or accessible over internet protocols. And that's a very important. Available everywhere. More important is on demand provisioning. So let me give you the best example. Today, that's a big bag sale is again going on Flipkart, we all know. Now, for the Flipkart, on the real Big Bang Day, when they had a huge or massive sale, what did happen? The website crashed. And the reason was they did not anticipate a huge load which was going to come. They might have, again, all the numbers might be fictitious, but just for your reference, I'm saying they might have expected around 20 million people. Just an example. It turned out that there are 30 million plus people. And so my only point to prove here is I won't say they underestimated the user, but that was a craze among the people to go and buy, and that has crashed the website. Now, what could have Flipkart done in this case? The one of the solution would be that if, for example, currently for 20 million they need 1,000 machines, instead they might have put 2,000 machines saying in an idle condition that okay, I need 2,000 in case the load increases. But have you thought about this 1,000 machine cost? That might be some few $1 million, and which might not be a very sustainable model, which might crash because you may use, you may not use, right? And then they might be idle for most of the time. Using them is always a challenge. How about if I tell you that I can get you 1,000 machines just for one day, and each machine would cost you maximum around $10? You would say, what? One machine for $10 in a day, and you can get me 1,000 machines such that so only $10,000 spending, I would getting 1,000 extra machines. That's amazing. That's the cost of my single machine. You are getting me 1,000 extra machines like that for a day because I need only one day. On demand provisioning. When I need machines, they are available to me. Okay, Tarun, you have a very good point. What if I add only if required, because I don't know whether the load may increase or may not increase. I go one step forward. Give me just 15 minutes notice. I would be able to add more 10, 15, 100 servers gradually as and when required. When your load is increasing, gradually your machine would increasing. Wow. Bingo. That's the scalable model. That's how it would be. You can scale up, scale down very easily. But how about cost, Tarun? Are you sure you would be charging me for a whole year? How? My dear friend, I'm going to charge you only for the amount you are consuming. So you run 100 machines for 24 hours, 100 machines. So 100 you ran for 24 hours, 100 you ran for 20 hours, some 100 for 16 hours, some 100 for 10 hours. Then I would charge those 24 machines at the 24 hours rate. I would charge 20 machines at the 20 hours rate. And 24 means 1 hour I charge you 15 cents, 20 cents. So 24 machines I would charge you around $4, $5. I put it at a higher rate, right? Here I would charge you $3 per machine. For 16 I would charge you around $2, something like that. So here the cost would be 500, here the cost would be 300. That's it. Pay as you go model. I'm paying only for the amount I'm using. But I agree with all your points and they look Jesse, they look amazing. How would that solve my problem? Or how do they solve their problem? How do they able to offer this? Because they offer you using resource pooling or optimal resource utilization. They use the concept called multi-tenancy. Now, does anyone know what is multi-tenancy? Does anyone know what is multi-tenancy? So Venkat should know what is that. I'll give you one more example and then I'll come back to this. Venkatesh is a very good answer. So I give you an example. Uh, Axis, HDFC, ICICI, those are the three largest banks, private sector largest banks across India. Now, when those one want to set up their own banking software, they went to, I think, Infosys or Finacle. So they went to Infosys and said, let's set up the Finacle for our banks. Infosys says, well and good, I can do that. Hold on. Axis says, I have a requirement. I'm a very secure company. So whenever someone comes to my page, first thing axisbank.com should show a security warning, how to treat and all that part. We don't share your password and all that. And then when he clicks login, take him to the login page. HDFC says I have open-minded. I don't care for all this. So whenever somebody comes to my HDFC.com, first bring him the home page only directly. But yeah, I need my blue and those red logos and all that one. I need that color combination. Okay. ICICI says I need all my color combination, but my first page should always be an advertisement or my product information page. My loans, FDs, and everything would be there. Then only the login page should come. Finacle says okay. Now, does it mean that Infosys has to create a 3 products for them? No, they can make just one product hosting in the data center, which might be catering to, see, that application might be hosted on multiple servers, catering to the ICICI, HDFC, and Axis, but they must have done some personalization at the application business logic, which would ensure that whenever somebody types axis.com, it would identify that this request is from Axis and would show the pages and the look and feel and the business logic according to Axis. Same way, when someone says ICICI.com, it would show the page of the products and the look and feel and everything as per the ICICI.com. This all would be from the same application. What is this all about? In this case, Axis, ICICI, and HDFC are the tenants of Finacle. And all end users like you, me, and someone else. I am Axis user. You are an HDFC user. Someone else is an Axis, ICICI users. We are the end user of that tenant. So a tenant system is nothing but a group of the users for whom the tenant is configured or deployed. A cloud provider configures an applications or gives you an applications for the group of the users. And how do they achieve this? This is again they achieve using resource pooling, where they optimally use the resources where from one data center, it might be serving the multiple tenants using the optimal resource pooling. Does it make sense for everyone? Are we all clear with the 5 attributes available everywhere? So available or accessible over internet protocols. You can, whenever you want, it is available to you. It's a scalable in nature, so it can scale up as and when required. You would be charged only on a pay-as-you-go model, and using multi-tenancy, it's using the resources optimally. Are we all clear with these 5 attributes? So Venkatesh says yes. Venkatesh says number of people, sorry. Will there be an integration of applications? Yes, there would be. So see, the question would be, what do you want to integrate? So there would be a multiple applications. Like Finacle, I just take an example. Finacle might be a combination of 10 products. Just an example. One would be the banking, one would be the customer management, one would be the finance management, one would be for the portfolio management. They might have made 4 products, they might integrate, but that might be integrated at the back end. For the end user or for the tenant, it would be a single application where backend it might be integrated. Is that what you are asking, Venkatesh? Or are you asking something else? Right. So this is how it would be. For the end user, it would be a single application might be working. You as a tenant, you might be accessing the single application. The backend level, cloud provider might have done a lot of integrations, because for the scalability aspects, if you join the curriculum in any case, I don't know, I would be also talking about the loose component or the decoupling and all that concepts I would talk about. which is the core of this integration and the web service calls. But it's very important at this juncture of time to understand the 5 attributes, and I tell you why these 5 are core or most important to understand. So I want everyone to say, are we all clear with the concept of these 5 attributes? Very clear? I request yes or no from everyone. I'm afraid I get yes from only 3, so I might have to take the names. Is it okay? So Priyavat, Rajiv, Vijay, Vimol, Prashant, Prashant just said, Ishwar, Alejandro, are we all okay? Any doubts till now? Okay, at least 80% are okay. That's good to know. Why this is important? This is the core of a cloud computing, a foundation of a cloud definition. See, if you go to the market and you try to read what is cloud computing, you would get hundreds of the definitions. Each definition would have their own meanings, and frankly, they are not easy to understand. They are not easy to digest. But if I make your life very simple, if you just want to, as a takeout, you want to take out from this session is just understand any business service, any business service. Now, what do I mean by business service? You are offering something application as a service model, like you are offering email, you are offering banking like Finacle, you are offering collaboration, you are offering CRM, whatever kind of a your application, if you're offering as a some service model, and that's a normal thing you offer as a service model, which follows this 5 attributes defined by NIST, is called cloud computing. Now, when you try to read any definition, they would mention about these 5 attributes in one or another way. So that's why I tried to just simplify language. So if anybody out of the world, and when you talk to someone and say, I want to move it to cloud, you can always say, do you know what is cloud? He says, oh yeah, I can store on the internet. No boss, that's not the cloud. Is your application available everywhere? I told you I can store on internet, so internet means everywhere. Okay, so you pass the first point. Is it available when I need it? Yeah, it's available. What's it's on internet, I can access anywhere. Okay, anyway, I make it. Is it really scalable? Hold on, what do you mean by scalable? It means today I have 1,000 users, tomorrow I have 10,000 users. Would your application be able to meet that load or scale up that? Hey Tarun, frankly I'm not sure. I need to check this, huh? Okay. Now, is your application really charge you on pay as you go model? No pay as you go. What is that? I already paid my vendor $10,000 and he's allowing me to use that. Boss, are you sure you are doing on already procured an infrastructure? Are you really going on a cloud? You have to think whether it's really cost effective or not. Is your vendor doing really resource pooling? What is resource pooling? I don't understand. Remember, I gave you the example of 3 banks, multi-tenancy, optimally using resources. Ah, I remember now, but I'm not sure if my vendor is doing that. Okay. Then I'm not sure you're using cloud. Any business service, whether it's an email, whether it's a hosting, whether it's a memory, whether it's a compute power, if it's available, followed by these 5 attributes, then and then I'll say it's a cloud computing. Else I would not do it. Let me give you a classic example. How many of you are using Gmail, the Google Mail? How many of you are using as a corporate, like your email would be hosted with the Gmail, email service would be hosted with the Gmail, right? You don't have set up your own email infrastructure. So I know the startup would be there. I completely agree with that. Boss, you all are using cloud day in, day out. You are. Gmail is one of the best example of the cloud. Gmail. How many of you are using Dropbox? How many of you are using Google Docs? How many of you are using Outlook? How many of you are using the uh, the Office 365? Even Facebook in some way. These all are the classic examples of the cloud computing. They all are cloud. In one or another way, they are the cloud. Now, to explain in a just one case to clear your doubts, let's take case for the Gmail. Gmail we all use day in day out. Now Gmail is one for the individuals like me, you, and then for the small, medium, large industry also uses the Gmail. Like Edureka itself using the Gmail as a mail server. In that case, what Edureka does is Edureka goes to Google and says, "See, I want to use your email infrastructure, but it should be customized for me. So my email ID would be tarun@edureka.co. Good. Gmail says I can do that. I'm using resource pooling. From same data center, I would be able to give to Tarun at your xyz@edureka.co, even at the same so tarun@im.a.co or tarun@iit.co or the tarun@xyz.co. They might be created because they all are different companies and Tarun is part of all these companies. Just an example. Don't quote me, I'm not anywhere. So IIT goes to the Google and says, see, we don't want to make our own email infrastructure. Why should we manage it? You manage. Just our ID should be like that. Cool. And you just register with us and you would get the ID something abc@iit something mumbai.co or in, you can get that. Optimally uses resourcing and using multi-tenancy, it's offering that. Now what? It's available everywhere. We know that. If you need new users, you want to increase the capacity, Gmail is virtually unlimited. It keeps increasing your storage. Plus, if you want to add more and more users, you can go and keep on adding there on demand. It's a scalable. Keep on increasing. You don't need to worry. It charges you per user basis. So you registered for 10 users, it would charge you for 10 users. You registered for 15 users, it would charge you for 15 users. This is the case. Gmail is the classic example of the cloud computing. Does it make sense? Are we all clear with the now cloud computing? What is cloud computing and the benefits of this? Can I tell that at least when you go out, you would be able to talk to someone, say, what is cloud computing? I would move on, don't worry. My only worry is everybody should be clear, then only I'll go on. Perfect. Now, what is the difference between cloud versus on-premise and the hosted one? See, generally, the leftmost is your own on-premise, something which you have hosted on your own environment. This is where you have hosted some other third-party provisions. And this is where you have hosted on the cloud. What is the difference between three? When everything is within on-premise, you have the full control. You own this. You manage this. But as I said, you have the complete responsibility, backup, high availability, disaster recovery, security, all your responsibility. And you have the power to do that. You can do as per your requirement. You would have the flexibility of tool, whichever tool you want to use, whichever infrastructure you want to procure. You can do all that. Yeah, it would incur a huge cost because you have to procure all the infrastructure. But more important is the control, more important is the responsibility. When you move here to the hosted mode, it's more like a rental mode. You would have a very less control. You would have a very fewer responsibilities. At the same time, you get the control flexibility. You can go there, you can touch something, but you would not have a full power over there because there would be multiple people's application servers hosted there. So your power or the control keeps decreasing, your flexibility keeps decreasing, but yeah, your cost also keeps decreasing. You move to the cloud, you get pay as you go model. So the most cheaper, you get the less control, you have the less responsibility, less bothers, but you get virtually unlimited infrastructure, huge cost savings, everything you would have. Only worry is you don't have a huge control. So you gain something, you lose something. It's now up to you which model you want to go. You want to go to the cloud model or you want to go to the hosted model. And that's why I bring some of the examples of the classic cloud. Cloud has a three models based on the services they are hosted: SaaS, PaaS, and AWS. SaaS is where a software is available as a service model. In PaaS, a platform is available like Google App Engine. You just create an application and give it to the platform and it would be taking care of that. In AWS, an infrastructure is available as a service model. All these would be the case. SaaS, PaaS, and AWS. These are the classic examples of the publicly available cloud models. So, cloud is there. Cloud is the need of the hour. Cloud is important. Cloud is now going to be the future of everything. You have to understand that. So, I bring this session of the cloud to a pause and I would like open for any questions or doubts. Do you have any questions, doubts, thoughts? Can I say at least that after the end of the session, when you go out and you would say, boss, at least I'm sure now I know what is cloud. I got the clear concept of the cloud now. If somebody says, what is cloud? I know that. Can you guys say confidently that now? That would make me the much more happier. That all my efforts are at the positive now. Can we say that? Bingo. Thanks, Venkatesh, for the feedback. Thanks, Alexandro. Thanks, Kunal. Cool. Okay. So let's go to the king of cloud, Amazon Web Services. It's a undisputed king, frankly. It's amazing Amazon. I use that word very frequently. I love the Amazon, and that could be the reason. But it's so powerful, so scalable, everything. Amazon Web Service is Amazon's offering of the cloud computing. Now we all know Amazon.com, we know Amazon.in, we know all that. We have that, right? We have the seller business. Amazon does have the seller business for that. So one part of the Amazon we all know is the largest online retail service provider across the globe. Second part is you can sell everything over there. And Amazon has a multiple businesses across the globe. So I would not go there about that. Now, third one is Amazon Web Services. That's Amazon's IT infrastructure business. Amazon is offering infrastructure as a service model, on demand, pay as you go model, available over internet, elastic in nature, using optimal resources. Amazon is the classic best example of AWS, though Amazon has a multiple, even it does have the PaaS kind of offering, it does have some kind of a SaaS kind of offering also. But Amazon started and leading in the AWS like no one else. And for that, because Amazon has a huge, unbelievable portfolio of Amazon products. It's having almost 40 plus products, and I would say your 80% need, except the coding, would be taken care by the Amazon. You want to host, Amazon has that. You want the analytics, Amazon has that. You want the automated hosting, Amazon that. You want the scalability, Amazon that. You want the load distribution, Amazon that. You want the queue service, Amazon that. You want the search service, Amazon has that. You want the data warehousing, Amazon has that. You want the static storage, Amazon has that. You want the Dropbox kind of case, Amazon that. You want the content distribution network, Amazon has that. You want the archival service, Amazon has that. You want the email service, Amazon has that. You want the workflow, Amazon has that. You want the transcoding service, Amazon has that. You name the things, Amazon would have that. Database, managed database, NoSQL database, caching services, monitoring services, automated deployment. You name the things, boss. I am ready to give you. And that's why I call it amazing Amazon. And it provides you virtually unlimited infrastructure thing. Now, why do I go for this part? Reason is, in 2004, when Amazon.com was there, Amazon was almost $7 billion plus retail business. They had almost 8,000 plus employees. Now you can understand to run those 7 billion plus retail business, you need at least hundreds, thousands, some kind of a service, right? I'm sure you would need that. Just an example, I'm putting a middle number 500. I don't know the number, right number, but that's because Amazon does not give that. But imagine similar kind of an infrastructure Amazon is adding every day to its data center. For example, to run that $7 billion business, it's adding those 5,000 plus or 500 plus servers every day. Similar kind of infrastructure it is added to Amazon's data structure or the data center. Whoa, isn't that amazing? That means you demand that keeps on increasing day by day. They keep on going on more and more and more. Virtually unlimited resources. Now I have a question and very good questions. How does Amazon achieve that? See, Amazon does the OR virtualizations. And so the question is, which virtual hypervisor does Amazon use? Amazon uses Zen open source hypervisor that is modified for the Amazon requirement. So Amazon uses Zen only, but for the Amazon requirement, they have customized that and it uses Zen open source hypervisor. But remember, every day you add that kind of a capacity. How does that work? Cool thing. And for that, I present you a case study. Now, that's the cricket fever is completely down in India these days due to this Bangla wash. Though we don't know it's a Bangla wash or what happens. But I talk a story about the February 26, 2010. Just a second. In February 26, 2010, Sachin Tendulkar made the ODI world record. He hit the first ODI double hundred. Now that we all know, and we are not here to talk about that. What we are here to talk about that, the crickinfo.com, which is the most famous website for cricket scores live, and I'm sure most of you would have visited that, right? Generally, they anticipate 5 million users average. On that day, they had 45 million page views. Can you imagine? Are you ever ready for that? From 5 millions to 45 millions. How would you match that? How would you reach there? No on demand, or how would you do that? Unless you are a scalable, unless you are a pay as you go. And what Sachin broke, he does not broke only the cricketing records, he also broke the Cricinfo website. It would be. Now, what can have been done here? What is the so problem? Let's try to see if in case Amazon was hosted on Amazon. Sorry, Cricinfo was hosted on Amazon. Amazon is already on Amazon. So yeah, just for your reference. If Cricinfo was hosted on Amazon, we first see the case if Cricinfo is not hosted on Amazon, what would have happened? So that is that traditional hardware. That's a blue line. Or let me take the blue pen only. The blue line shows. So for example, in 2003, we just start a little early. I am a storyteller, so I go with the history and stories. So in 2003, Amazon's or the Cricinfo might started with a user base of 50,000 something, and they might need around 500 machines for that. Just an example, or 50 machines for that. For the 50,000, they need 50 machines. So somebody says they are not able to see my screen. I hope, is everyone able to see my screen? I have written down 2003, 50K, 50. Are you all able to see this? So Rajiv says yes, Prashant says yes, Venkatesh says yes. So I guess Amit and Alexandro, I guess it might be issue at, sorry, Amit and Ishwar, it might be issue at your end because everyone else is able to see that. So not sure then because it might be issue at your end because everyone else is able to see that. Yeah, coming back to Amazon, oh sorry, Cricinfo, suppose on the 50,000 users, they had only 50 users or 50 machines. Then they were able to meet that. But now we know that load is not 50,000. In 2007, they might have procured more infrastructure because World Cup is coming, India is booming, everything is there. They say now I have almost 5 million users. I would need almost 5,000 machines. in 2014 or 11, after that onslaught of Sachin, we say they might have saying that okay, let's go and procure for 20 millions. So they might have a 20,000 machines available. Now, what is the actual situation they have? I just use some different pen. Actually, their usage is much different. Most of the time, when it was 50,000, the usage was 30,000 at peak. Else it was 20,000, 10,000, because based on the match, it would keep on changing, right? It would keep on changing. Now, only once in a while, it might have gone beyond 50 years, around 60K something. We can say again, that's a Sharjah story or something like that. Sharjah was actually in 90s, but something like that, where the usage might have increased. Otherwise, it is much down. They increased the power to 50 million. So what happened in most of the in 5,000 machines with 5 millions, their actual usage stays almost around 1 million, not more than that. And when there is no match, they are much lower than that also. They are back to 50,000 users also. So that gives you what? That gives you that most of the time their resources are underutilized. You have an infrastructure capable of 5,000 machines, but you are using only 1,000 machines. What are you doing? 4,000 machines you are wasting, aren't you? It's a problem, right? There is a huge improvement cost required. You are not bothered to see that, you are not bothered to connect that. That implies your huge financial cost also implications, correct? How do you overcome this? How do you overcome all this? Easy solution. Why don't you go to the cloud? Now in 2003, we did not have the Amazon, but just in case, if we have the Amazon, what you can do is you can always launch Amazon with 10% more requirement. Suppose for 30,000 users, you need 30 machines. You launch 33 machines. For 5 million users, or here, when I say go here, somewhere here, here you need 1,000 machines. For some case, you launch 1,100 machines. So you are always little bit having a more bandwidth to available. Here you need 5,000 machines. You launch 5,500 machines. At the same time, important is when you have no load, you are at a 2,000 requirement, you are running only 2,200 machines. So you are running machines 10% more than your requirement. Still, you are running only what your requirement. You are not unutilizing the resources. You are not wasting your resources. You are saving a huge amount. And this you could do with the cloud because it gives you powerful tools of using resource pooling. It can offer you pay as you go, on demand scalability. So you run for 1 day, 2 day, on that fatal day, even if you might have run those resources of your Cricinfo case, just for that 1 day, you might have added 5,000 additional machines for 1 day. You are paid only for 5,000 machines for the 1 day only. You don't need to procure from the beginning. That 5,000 machines cost of 1 day might be equivalent to your 10 machines cost if you procure that. Isn't that amazing? Isn't that a great thing to use? Isn't that the advisable? Why would I waste my money unless I have some specific reason for that? If somebody is giving me, again, security is there. They do provide the all kind of security mechanism. They give you scalability, automated. They give you all automations. They give you all the kind of a services. Then why do you look across the world and not seeing one which is next to you on your computer? The name is Bond, Amazon Bond. What do you say? What would you use in this case? It does make sense, and thanks Venkatesh for that. It does. It is the must thing. Now let's see how do you design for the cloud. Now I would be explaining. Unfortunately, we have some time limitation, so I would not be able to go in depth of each and every. But I assure you, in case if you happen to join our curriculum, the next batch would be starting from the 11th July. Even one might be starting on, but I would be taking the batch from the 11th July. So my next batch is from 11th July. I would be going in depth about all these aspects and how it would be working out. So what are the key important aspects if you want to design a scalable systems? You have to have the load balancing. You have to distribute load among the multiple servers. You have to think on the database scaling. Now database is not easily scalable aspect. So you have to think on a various different aspects like sharding, caching, consistency, and multiple things, read-only database. You have to think on various aspects and then only you'll be able to scale up. So you think about the caching also for improving the performance, reduce the load on the server, reduce the load on the database. You do the automation and monitoring, and I'll assure you, you would get the real scalable system to use with. So this is how the your normal application if design in the Amazon would look like. These are they would have a load balancing offering. They have the route mapping for to the domain name mapping. You can use the software based load balancer. You can use Amazon's load balancers. You can use the web tier, app tier. I would be able to explain again. I might be sorry, but I would be able to explain more in detail if I go to that in curriculum, because EC2, I believe couple of you know, it's a virtual server available on demand. Amazon does offer the database called the RDS. That's a master slave. You can see at the bottom. Amazon does offer the load balancing with the ELB. Important aspect is it helps you to decouple the components, achieve that better disintegrations and the real scalability aspect. And to achieve the real scalability, the three most or core foundation service of Amazon is Amazon Elastic Load Balancing, Amazon Auto Scaling, and Amazon CloudWatch. We would explain in detail with the practical and demo, but give you a little perspective of that. These three services work amazingly. Again, I use that word so frequently. Sorry. So amazingly together when they and give you the real case. To give the case of the quick info, generally, your application would be configured with the load balancer. So all load would be coming to the Elastic Load Balancer. It is there. The load would be coming to the Elastic Load Balancer only. It would be, and when all application traffic would be coming there, that would be the, you might have a multiple Amazon servers running beneath that Amazon's load balancer, which would be distributing traffic across those machines. So your load would be distributed. Your one server might not be loaded huge. You would be monitoring all those resources at regular interval using Amazon's CloudWatch. Amazon CloudWatch is a monitoring service of Amazon resources. And whenever it finds certain threshold, for example, you say whenever network IO of a machine is more than 10,000 bytes, or whenever CPU utilization is more than 50%. In this case, you say scale up. So you would notify Amazon scaling service called auto scaling. Automatically, it would add more resources for you. So take the example of Cricinfo. When the user increase from 5 million to 10 million, Elastic Load Balancer would send traffic those 10 million to those multiple servers. Now, since they were used to with the only, so each machine is getting around 5,000 users, just an example. Now they are getting 10,000 user requests. So their CPU utilization has increased, their network IO has increased, which they are not used to. So CloudWatch, which is monitoring all these resources, would say, boss, there is something wrong happening. It would notify auto scaling. Auto scaling would automatically add 100, 500, 1,000 servers as per your requirement or configuration, which would be again part of this load balancing service. Automatically add those resources here, and now the load would be distributed. Instead of 5,000 machines, it would be distributed among 6,000 machines. Automatic, no manual intervention. Completely automated way it would be doing for you. So when these three services are working together, they would be doing wonders for you, giving you the real scalability aspect of the Amazon. And that's why I show you one of the highly available website architecture, where we would be saying that this is how the Amazon architecture would be proposed. You would be having the high availability scenario. You would have a various services there. Amazon offers a zone concept, which is a different data centers for high availability. VPC is a private subnet for the security aspect. You would have a load balancer. You would have a CloudFront for the static content distributions. You can use the Amazon's email service for the mailing. You can use the CloudWatch for the monitoring. You can use the caching service of the Amazon. So you can do multiple things here as per the requirements. This is how the highly available architecture of the Amazon would look like. You can also use the NoSQL database called DynamoDB for some caching purpose. And this is how we would be using the various services of Amazon. So all domain name, when you want to map the domain name like edureka.co, I want to map to the Amazon's load balancer, I would use Amazon Route 53 service, which is a domain name mapping service. For static streaming and dynamic content, I would use the Amazon CloudFront for the content distribution network. It is like Akamai kind of a case. I would have the Amazon Simple Storage service for the static storage service. I would use the load balancer for the distributing of the load across the zones. I would be using the auto scaling and EC2 for the hosting and the scaling of the services. I would be using the relational database of the Amazon because it's managed, and I might use the DynamoDB as a NoSQL database. So, my dear friends, this is a generic overview about the cloud computing, a generic overview how can you design a scalable system with the Amazon Web Services. Now, our curriculum is going to change a little bit. So, what you see on the screen is, I would say, 80%. We might be increasing more. So if you join the 11th July batch, you would have two more sessions. One would be more important called VPC and Route 53. We are also going to cover that. We are also planning to cover the more about a case study case of the Amazon also over there, how to migrate to the cloud. We also talk about the architecture design, and at the same time, we would be talking a lots of a hands-on. So assuring you that at least we prepare you in the right direction of achieving Amazon certifications. So this is all about the overview of the cloud computing. This is all about the overview of the Amazon Web Services and how can you make a scalable application with the Amazon design over there. With this, I bring my session to end, and I'm open for any questions if you have. But before you run away and before I answer any questions, I would like to know from you, what is your thought, your feedback? Did you like the session? It's a great. I found something missing. Your thoughts, your suggestions? So thanks Rajiv, thanks Ishwar, thanks Venkatesh, Amit. You can always connect through my LinkedIn. Definitely. I'm not sure how much I would be. Yeah, I would be able to answer some of the things, but not sure how many. Based on my availability, I would definitely help you. And I hope you all had a wonderful time today. You all enjoyed this. Our curriculum will definitely help you for the certification. So if you join us, I assure you, at least it will give you the right directions. It would give you the, or it would ensure that you know all the basic and the important things to prepare for the certifications. Now you just need to give a little last mile connectivity you would need to reach there. So Rajiv says, I am a 5 years of cloud AWS data center service. Will this certificate gonna help me? See, I would not answer whether that would help me or not. I would just answer in a generic. Amazon is in demand. Frankly, I myself getting almost 1 to 2 requests or more than 2 requests every week for various kind of Amazon need. And it's in demand. Amazon certification is in huge demand. So if you are thinking something for going to the Amazon, you are thinking for exploring Amazon, you want to learn Amazon, I assure you this curriculum would definitely help you. And if you get the certification, there is nothing like that. It would be the perfect case for you. So Prashant has a question, what would be the pricing of this course? The pricing and all that, you can drop a mail to our sales team. You can drop a mail to me and I would be able to connect to with our sales team also. Right? Anything? And I'm sure. Thanks again, Ishwar, for your feedback. My only worry is, I think I mentioned my mail ID in the first slide only. It's a tarun@edureka.co. That's my email ID.